Hey GED students, I had a student on Facebook contact me who is struggling with some circle application problems, which granted are pretty challenging. So let's take a look. You're going to want two tools with you as we do this, and you'll have these same two tools as you go to take your GED. You want your calculator, your TI-30XS multi-view. Now, if you don't have a multi-view, okay, fine, use some other calculator, but I highly recommend that you either buy one or you download the 90-day free trial from Texas Instruments so you can practice with one before your test. And then you're going to want the GED formula sheet, and that's easy to get. Just Google GED formula sheet, print it out, and those two tools are going to help us as we do these circle application problems. Let's take a look. It says the minute hand on a grandfather clock is 8 inches long. What is the circumference of the circle to the nearest tenth of an inch traveled by the minute hand in 1 hour? Guys, do not try to do this problem without drawing it. Anytime you have a visualization, I don't care if it's, your backyard or they're talking about a jacuzzi or the face of a grandfather clock, you need to see it. You need to have that image of what's going on here. So let's draw ourselves a little grandfather clock here. They did tell me that it was forming a circle. So even if you're not super familiar with clock faces, you could know that. So there's my little grandfather clock. And then it said the minute hand on a grandfather clock is 8 inches long. Let's think about the way a minute hand works. It goes from the center of the circle to the outside, has that little arrow on it. And they're saying this minute hand is 8 inches long. And then what are they asking me for? They're asking me to find what is the circumference of the circle traveled by that minute hand in 1 hour. So hope you guys know that in 1 hour, the minute hand goes around once in a circle. Okay, so basically, how far is that minute hand going to travel? Well, it's going to travel in one circle. The outside of a circle is known as its circumference. So hit up that formula sheet, the GED formula sheet. In the second section down, the perimeter section, very last formula you see, very last line in the perimeter section says circumference of a circle. But you're going to notice it gives you options. There's two options. It says C equals pi, that little symbol is called pi, d, or C equals 2 pi r. And you might say, well, Kate, which one do I use? And it doesn't really matter, actually, to be honest, which one you use. They'll both get you the same answer, but one's easier, I think, than the other. I prefer to go with the one where I know what information I need. Let me show you what I mean. This formula has a D. D in circle formula stands for diameter. The diameter of a circle stretches through the center from end to end. This formula, on the other hand, has an R. R stands for radius. The radius of a circle goes from the center to the outside, much like that minute hand. Since I already have the radius, I'm going to go ahead and use the formula with an R in it, and I'll just ignore this one. So here we go. We're finding circumference, so that will remain C. Numbers stay numbers. Now, pi is a number, not a variable. It's not something that changes. It's always the same number, but it's an irrational number, a number whose decimal form goes on and on forever. Obviously, I don't want to do math with numbers that go on and on forever. So you may use the rounded version, 3.14. That's an approximation for pi. And then R, my radius, I said was 8 inches. And now that I'm all substituted in, all I have to do is multiply out. So let's put this in our TI. 2 times 3.14 times 8 gives us 50.24. Now that I have my solution, two things I should do. I should check for any rounding directions, and I should figure out my unit. So let's go look to see if we have any rounding directions. I see some rounding language here. Notice how it says to the nearest tenth of an inch. The tenths place is just the first one after the decimal. So here's the tenths. So I'm going to cut it off after the tenths place. Ask myself if this number I'm throwing away is big enough to matter. It's not, because it's not 5 or higher. And so I'll just call that about 50.2. And 50.2 what? 50.2 inches. Since circumference is a line around a circle, it is a linear plain old inches measurement. All right, so that's my first example, but you had a few, so let's look at the next one. Okay, next one got a little trickier because it says, what is the distance traveled by the minute hand to the nearest tenth of an inch of the clock in the last problem, in the clock in the last problem over the course of a half an hour. So let's go grab up the clock in our last problem. Okay, it was a circle with an 8-inch minute hand or radius. And it's almost the exact same problem, but this time I want to know how much it's going to travel over the course of a half an hour. And students lose their brains. Like, how could I ever figure out a half an hour? What am I going to do with half? And I'm like, guys, half of an hour? You're going to take half of the circumference. And remember, of means multiply. And we just figured out the circumference. Let's go back and look at it. The circumference was 50.2 inches. So guess what? If in a full hour he goes 50.2 inches, in a half hour he's going to go half of that, half of 50.2 inches. So I saw the particular student who sent me this used 0.5 for 1/2. You certainly can do that if it's easier to type in your calculator than typing in 1/2. So 0.5 times 50.2. Still, other students would divide by 2 in order to find half of something. It'll give you the same answer. Okay, so I get 25.1 inches this time. All right, hey, that problem was easy after doing the last one. Now you see why I included the last one in the video too. All right, so good with that one. Let's look at the next one you sent. Said a merry-go-round consists of a spinning disc 10 meters in diameter. Okay, guys, what's a spinning disc? Oh, that's just a circle. Okay, and they said 10 meters in diameter. So they said diameter this time. I'm drawing that line through the center from one side of the circle to the other. That's a diameter. And then it says to the nearest meter, how far would a child who is clinging to the railing around the outside? Here's that kiddo dangerously risking their life on a merry-go-round clinging to the outside. How far are they going to travel in one revolution of the merry-go-round? Okay, let's think about the way a kid will travel on a merry-go-round. Does the kid go around in a circle? Because if he does, that'd be circumference. Or does the kid cover the entire space of the merry-go-round? No, that's not how it works. He goes around in a circle. And so this is another circumference problem. And again, we have those options. I can use c equals pi d, or I can use c equals 2 pi r. Well, this one time I have the diameter. So guess what? This time I'm going to use the formula with the d in it. Again, you could use the other one. It would just take more work because then you would have to figure out, well, what's the radius based on the diameter? So this way I'm just using the one that already, I know the d, so might as well use this one. Okay, so c is equal to, we said pi, we could use that approximation of 3.14. The diameter of my circle there is just 10 meters, and so I do get, I don't even need a calculator for that one, 31.4. And let's see if there were any rounding directions. To the nearest meter. That throws students a lot. When I just say to the nearest unit, like to the nearest inch, to the nearest meter, to the nearest foot, they don't know where to round. Round at the decimal place. They're talking about the nearest whole meter. So no pieces, no parts. Okay, so I'm going to round right here at that decimal place. Again, that 4 is not big enough to matter, so I'm going to say that's about 31 meters that child is traveling. That's a huge merry-go-round. It must be, I wasn't thinking straight, obviously, when I wrote this word problem. 10 meter long? That's like 30 feet-ish. Must be at a fair, not at the park. All right. So 31 meters is the answer here, and let's look at your last problem. It said the area of a certain circle is about 42 square millimeters. What is the radius of the circle to the nearest tenth of a millimeter? Okay, again, this is an application problem. This one's a little more straightforward, but still, this time I know the area and I'm solving for the radius. What is the radius? I know the area. I'm solving for the radius. So I am going to bust out that area of a circle formula. Again, hit up your formula sheet. Areas, formulas are the very top section there. So very first section you see says area. Go look up the area of a circle and you will see the formula says A is equal to pi r squared. And you're definitely going to want your calculator for this problem. I promise. Okay, now let's plug in what we know. So be super duper careful. This number 42. You cannot just plug it in where you feel like plugging it in. You have to plug it in where it belongs. That number 42 is what? That is the area. It says the area of a certain circle is 42 square millimeters. So you have to plug that 42 in for the area. Even though this makes it a kind of a challenging problem to solve, you still need to do that. Now pi, once again, is a number, not a variable. He's always the same number. And we just call him pi because he's so long, but we can go ahead and use that decimal approximation, 3.14. And that is on your formula sheet if you forget it, you guys. Okay, so 3.14. And then now, I don't know what r is. See how this says, what is the radius? This is my mystery. In algebra, when we don't know something, that's when we use a letter. So I'm going to use r, and it's going to be squared. All right, so this is an equation that I need to solve. R here is not alone. I need to work to get him alone. Now, be really careful. When you're solving equations, you're supposed to work the order of operations backwards for solving. So you should move any numbers adding or subtracting with R first. Well, I don't see anything adding or subtracting with R. Next thing to move is anything multiplying or dividing with R. This 3.14 is a multiplier, so I am going to move him. Now, we always move things to the other side of the equal sign by doing the opposite. I'm going to divide away 3.14. Now, that is legal if and only if you keep your balance. So jump on over to the other side of the equal sign, do the exact same thing so that the left and right hand expressions remain equivalent. Okay, so on this right-hand side, multiplying and dividing by 3.14 are opposites. They will cancel. And careful, I'm not just left with r. That's an r squared over there still. And then this is why you'll really want your calculator. Whenever you're multiplying and dividing with decimals, life can get ugly. So let's try this. 42 divided by 3.14. And I get this beast of a number. And I'm not going to write it all down. It's like 13.37579. But I am going to put the ... because I'm not going to erase it out of my calculator. You want to be careful not to round until the end of a math problem, because if you lose your information too quickly, you could get an inaccurate answer. Okay, so I'm going to keep the whole long number in my calculator. Now, careful, a lot of students will just stop right here. I'm done, yay. No, you're not done. R is not alone. This little square is still hanging out. You've got to get rid of a square. And a lot of students forget, well, how do you get rid of a square? Like always, you do the opposite. The opposite of square is square root. And like always, I can do whatever I want to an equation as long as I do it to both sides. So I'm going to take the square root of the left-hand side as well. Well, on the right-hand side, that's super duper easy. Square and square root cancel, leaving me with just r. And on the left-hand side, let me show you how to type this expression into your TI. You can take the square root of an answer by hitting second, and then right above the x squared button, that's where you see that square root, so you're going to hit the x squared button. And now you're just going to use your up arrow to arrow up to that number that should still be in your calculator. Remember, I told you not to delete it? Arrow up to that 13.37 answer and press enter to select it once it's black. Then press enter again to get your solution. And now I've been so busy writing about it, I haven't done it. Let me do it in mine. I don't have a TI in front of me, so I'm trying to do it with a different calculator, and I'm having regret issues. Oh. I have to figure out how to do this in my phone calculator. I should have brought my TI, you guys. I know just how to do it. There we go. Okay, and I get this radius of 3 point yada yada yada. I'll write it down. Now let's go back and see if we have any rounding directions. It says, what is the radius of the circle to the nearest tenth of a millimeter? Okay, the nearest tenths are the first decimal place, or the first number after the decimal place here. So that's my tenths place. I'm going to cut it right after the tenths place and consider the next number, the one I'm about to throw away. Now it is 5 or higher, and so it is going to make a difference to this number before I throw it away. It's going to bump it up. So instead of 3.6, I'm going to call that about 3.7. 3.7 what? 3.7 millimeters. Even though area is measured in square millimeters, a radius is just a line. So it's going to be measured in a plain old linear distance unit, in this case millimeters. All right, holy moly, we worked some challenging circle problems. If you have any questions about these problems or any other GED math topic, be sure to drop them in the comments and I'll do my best to answer them.